Well, hi, good morning. Thank you so much for joining me in my shop here. It's March 12th, and it's going to be a nice day today here. I think it's going to get up to 11 degrees, so pretty much spring is moving in here, I think. If I can say that optimistically. I can't imagine it snowing again, but you never know. So what's up with this radio? Well, everything's been sorted out in terms of old capacitors and the like, and a few other little odds and ends have been fixed up, and now it's time to check and adjust the alignment of the radio. So there's kind of two major parts to that. The first part is called an intermediate frequency alignment, or an IF alignment. And that involves these two cans and these four holes here. If you look in, you'll see there's some screw heads in there. Those are on trimmer capacitors. There's actually two coils in each of these cans. It's a one trimmer for each coil. So there's a primary and a secondary on a transformer inside here. And they need to be tuned to a very particular frequency. And for this radio, it's 456 kilohertz. For most radios, it's 456, not much different. Some of them are 460. Really old ones have very low IF frequencies, and hundreds of kilohertz, not like 160 kilohertz, stuff like that. So this is a little higher. That frequency, by the way, the IF frequency, is just below the AM band. So you see the AM band ends at 550 kilohertz, and the IF is down here at 450 kilohertz beyond the range. So the radio cannot tune in its own IF. That would be a bad thing. Why would that be a bad thing? Well, because it would pick up the output from the IF and direct it back to the antenna, and it would come around again. Did that make any sense? Did I just say something that didn't make any sense? It would pick it up out of the air on the antenna. So the radio is issuing a frequency about 456 all the time, a little bit, or especially when you tune something in, and that could come right around and come down the antenna if the radio could tune down low enough to pick it up. Why is that important? It's not. I am wasting your time, wasting mine too. So let's move on here. What I need to do is set up the signal generator over here, my old military generator. Get it running at the 456 frequency. Pilot into the antenna. No, I think they want you to attach to the grid cap of the 6A8. I don't need this here. 6A8 tube. So this is the 6A8 tube. I can see right on it. 6A8. They want to feed a signal into here. Look over here. Into here. You notice the wire coming to the grid cap here on the tube goes right back to the tuning condenser. Well, almost as if the antenna is connected right to here. It's probably more or less the case, except it's probably running through this coil. Now, I'm not sure. I'm not sure what this coil is. I mean, it could be a local oscillator. It could be an antenna coil. Got two trimmers on it, so I had the feeling this is the local oscillator coil, and underneath are all the antenna coils. Three of them for reasons I don't even know. Hey, one of them must be the trap. One of them must be the IF trap. You don't want the IF frequency, that frequency down here that the radio is never supposed to hear. You don't want that coming in on the antenna from another radio somewhere that's barking it out, unfortunately. And you don't want this radio sending it out on its antenna to your neighbor's radio, which is not a concern in the modern world, but back in the day, it was. So there's a circuit called a trap in here somewhere. I see another adjustment. I hadn't really. This one is way down here. That's an adjustment. That's an adjustment. That's an adjustment. There's these two. And then underneath there were three more trimmers, three more of these guys underneath. There's a lot to do here. So the first stage is the IF. The second stage is all the rest. The idea of these radios is kind of interesting. Rather than have all the circuits all the way through the radio tuning to the station you want, what they've done is they've designed the radio with a fixed frequency in it. And the frequency is the one I've been mentioning, 456 kilohertz. If you can supply the radio with 456 kilohertz, you'll hear it come out of the speaker, more or less. Any other frequency won't make it through. But wait a minute, the radio tunes, 680 kilohertz and 1010 kilohertz. That's not 456. How does it get through the radio and come out the speaker? It's because the first thing that's going on in the radio, one of the first things, is the converting of the frequencies being picked up on the antenna to the IF frequency. So there's a conversion going on in here, a frequency conversion. So the idea of that is you can design these for one single frequency really, really well. As soon as there's a range of frequencies, you have to have something accommodate a range of frequencies, then you can't make things as sharp as you might want. I guess that's an appropriate word for it. You can't have this flexibility and have a high performance at the same time without a lot of trouble. So this is a way to get high performance, minimize the trouble, minimize the number of circuits being tuned as you turn the knob to almost nothing. There's almost nothing being tuned. What's really happening is this local oscillator frequency is being varied by the tuning knob. And that local oscillator is being used against all the signals coming in on the antenna to shift them over, or to reproduce them again at a different frequency. Now that's probably even a more accurate way of describing it. You're really creating a new set of frequencies in the range of the IF, around 456 kilohertz, and any that are exactly 456 through the radio. That's another terrible explanation of this. Sometimes I get the explanations good, sometimes not so good. I just want to reduce the amount of stuff on my bench here a little bit. Oh yeah, I've got to turn on the signal generator here. Now we're going to look at the instructions. Should be able to get 456 up here. That's roughly it. Let's take a look at the instructions here. The instructions for models, that's the model I have, 5542. So I've been talking about the IF alignment, intermediate frequency alignment. Set the service oscillator to 456. I just about did that. The oscillator lead connected to the 688 grid cap. They don't say anything about a capacitor or anything being used in here. Adjust the trimmers. These are the four I was talking about on the top of those cans for maximum output. We'll need a meter to measure the output. We can't rely on our ears for this. Selectors should be turned out or opened while making these adjustments. So when they say the selector, they mean the tuning capacitor, and they suggest it be completely open during this process. So I'm going to do that right now, or else I'll forget when the time comes. That's just to reduce the amount of interference that might occur while you're doing this. And then after that is the IF rejector. Set the service oscillator, same frequency, output lead attached to the aerial, or the antenna of the chassis. I guess they use the word chassis, I'd use the word radio myself. Adjust trimmer, C7 for minimum output. You're trying to trap this signal. Caution, make sure the chassis is not tuned to a harmonic of 456. So, okay, we don't want that to happen. You'd be trapping out a frequency that's actually in the AM broadcast band. You'd be trapping out some of the radio signals. Well, this doesn't look very complicated, not a lot of words here. We won't worry about this part yet. Let's just do this IF alignment, IF rejector. The usual word here is trap. IF trap. So, okay. I think I'm ready to go. Okay, I think we're all ready to go. Let's turn the power on to the radio. And while that's warming up a bit, we'll adjust this to 456. I'm going to be moving it around anyway, so it doesn't actually matter right at the moment. 455. So we have to add 1 to this number to get a more accurate idea of what the signal generator is doing. The output power level is controlled with this knob. There's a multiplier knob here. Right now it's on times 100 watt. So we'll put this here, we'll turn it down very quickly. So I'm setting the meter to the top of the scale here. That's calibrating the unit. So now it's putting out 10 microvolts times 100. So that's 1,000 microvolts here. What's on the end of the cable here is over here. Well, it could be a little different from various effects that can happen, but it's going to be good enough anyway. I don't need the precise amount. I'm just wasting time here letting the radio warm up a bit. Let's give it the full power. Turn it up a bit. There we are. Okay, it's operating. Oh, you know what I forgot to do is hook up the meter to read the outputs. It's okay if I give the radio more time to warm up. That's fine. Okay, and this, I want to hook this up. What's that mean? What was that? Boom, boom, boom. I came out of the radio there. Didn't really like that. Okay, so we're going to set this on AC. We're going to set it fairly sensitive. Let's do 1 volt. And I'll clip this onto the voice coil connections of the speaker. That's one. Wonder what that's going on there. Okay, we'll put this on here. Turn the volume up, we should see the meter go up. Good. Make the meter more sensitive. Good show. It's just nothing loose. The popping sound has me a little, I wouldn't say concerned, a little curious. So now we're not hearing the 456. I have not hooked it up yet. So I have the output from the signal generator here. One lead, the black one, is on the ground wire to the radio. And the other one's going to go on the grid cap of this tube. There we go. So it's silencing the radio because the impedance of this circuit, or the resistance, is very low, in fact. So it's knocked out any radio signal coming in from what little antenna was connected. But I don't hear the tone. I don't hear the 456. We should hear a 1,000 hertz tone. Should be a whistle coming out of the speaker. So I think we can say, let me turn this up, because oh, there it is. Sometimes you need a pretty good power, a pretty good signal fed in here. So I'm going to turn this dial, and we're going to watch the meter, and we're going to see where the peak occurs. And I'm going to move the camera out of the way here. Put it like this. That's a good shot. Okay, here we go. Watch the meter. Well, you can hear it. Peak seems to be somewhere in this area here. And the meter's hardly moving up. I get a little more volume here. This is going to bother me. I do this. Okay, it's a little easier to listen to. Turn it up. We'll go again. So that sounds like the peak or a peak, and the frequency we're on here, 440. It's supposed to be 456. That's 15 out. That's a pretty good chunk. That's a fair bit out. But let's tune further up and down just to see if there's something else going on. Go down. Nothing. Okay, go back up. Okay, 442 this time. Same thing. I will go up. Watch the meter. And it never comes back. Very good. So, what that suggests to me is these are all tuned to the same frequency, but the wrong frequency. How that happened, we don't know. Somebody did it, just did that over time. I don't know. So we're going to start moving this. Start with the, I would say, first IF, second IF here. So we'll start with the second IF. Start with the second IF. Doesn't really matter in the end. If a radio were way out, then it might be tricky to do this. But with a radio largely operating, this is not hard to do. Let me turn to the correct frequency now. Okay, so it's... I can just barely hear it. There, we can hear it there. Okay, peak it up. Oh, watch the meter. The screw is stuck. So these screws are often stuck, and they need to be started with a stronger screwdriver. Let me try this guy here. There we are. I might as well loosen them all up here. Ooh, lots to be gained. You can tell already. Okay, they're all loosened up. Because an insulated tool is just a little better to use. Okay, checking the frequency on the signal generator. It's correct. Here we go. Watch the meter there. Okay, I'm going to turn this down. You want to do this with the lowest signal you can get away with. There's a huge difference occurring here. You know, this radio was working well. Well, it could be that all this was tuned nicely, but on the wrong frequency. So you're still getting a nice operation. It's just the dial wouldn't be accurate, and a few other things would happen not quite right. And I'm moving it now to its proper frequency. It looks like I'm peaking it up. I'm not really peaking it up. I might be peaking it up somewhat. We don't know. If I didn't do that, little check. Let's try this again. Now that I've talked, I forgot what I was doing. Where I got to. Can you hear that? Listen to the sound of it. So I can't demonstrate. I was going to demonstrate how this affects the tone of the radio. It has a big effect on the tone of the radio. So I'm going to do them all again. We're on the right frequency. Some radios, these are very sharply tuned. Like this one's pretty sharp. Others, not so sharp. This one's very, very sharp. It is possible to get this too tuned up, and what you'll end up in, when you listen to the radio, the highs will be missing, the treble will be missing. But that's probably not going to happen with this radio. Okay, so we've tuned up the IF. We don't know for sure how much of a boost we got because of the way I did it. Now we're going to move this from here to the antenna. And then we're going to adjust that trap. Where was the trap adjustment? I don't know where the antenna. It's picking up a station right now. Where is the trap adjustment? Okay, I have to stop for a moment. Well, let's go looking. Let's go, let's see if we can find it. No, I'm going to stop. Okay, let me just turn the radio down here. Okay, so here's the different chassis for the different models of the radio. 542 models. Oh, bottom view. There is a bottom view here. Okay, very good. So we're looking for something called the rejector. We're looking for the rejector. IF rejector trimmer. Right up on top of this, L1. It's the upward facing one, not the sideways facing one. And the other one is the RF trimmer. We'll get to that. So this is what we need to adjust next. Then the objective is to adjust it so it knocks out the signal from the signal generator, which I don't hear much right now anyway. But let's go take a look. Okay, so this is the guy right up here. I'm going to turn up the signal generator here. Okay. So it's a pretty strong signal now. And we'll adjust the trimmer. You know, watch the meter. And the object is for the meter to go down. Turn this up a little bit. To the lowest reading. Okay. So what's happening here is we're now feeding this internal frequency, which has no business being on an antenna. We're feeding it into the antenna, and then I make an adjustment to trap or reduce that signal so it won't go further into the radio and come right through. In fact, it would come right through and come out the speaker. We don't want that. And vice versa. If there is some local oscillator going the wrong way, the trap will catch it also. Okay. Well, that's it for the first stage of the alignment. Next stage is the RF stage, much more complicated and a little more problematic, probably. Why don't we just tune this guy around a little bit before we do the next thing? So I just walked in here, and voila! When I turned off my signal generator, how could that have an effect? I can't imagine it does. Huh. You know what could be happening here is with no signal fed to the radio, the AVC voltage goes to its lowest level, weakest level, and the radio's sensitivity goes up to its maximum. And at that maximum, I think we're getting the putt-putt happening. Maybe the rest of the alignment will solve that. I'm really not sure that it would, but let's keep going. You don't normally listen to a radio with no antenna hooked up to it. So, speaking of which, we are about to hook up an antenna. So let's see what happens here. I'll disconnect from the signal generator. Yeah, look at that. So by turning off the signal generator, I removed the signal from the radio. The radio's AVC has now turned up the sensitivity of the radio a bit. And I think that's where we're getting into this trouble here. That's my theory. Now that's interesting too. Having disconnected that, made the sound go away. That's hard to explain. It doesn't fit with my theory here. Okay, we're going to hook up to the outdoor antenna here. We're on a broadcast band. We're at the high end. So I think this is 1580. I'm not sure. At the high end of the band, outside of the city of Toronto, there's quite a few, or near the city of Toronto, there's quite a few community radio stations broadcasting with, under a kilowatt even, and I can pick those up during the day. So this is one of them here. I don't know what it's. It's a community thing. It's broadcasting in a language other than English. It's a very characteristic sound here as I tune this in and out. The swooshy sound. Now this is on a pretty good antenna, but it is working really well. This is really, really good reception. Chinese? Chinese, I'm pretty sure of that. Don't know what's going on there. That's happening at 1400. Oh, it's a weird thing.
Now, and yesterday in putting together some charts, I noticed yet another bearish divergence. The all-time highs that we've had this year have been made on less bullish momentum than the all-time highs made last year.
So I think this is 1150 from Hamilton, and this is Bloomberg Radio. I listen to this. Really good journalism. It's just it's all business oriented, so but it's very, very good journalism on Bloomberg.
Upturn, but it's still below. So another bearish divergence. Just
lack of success in playoff games or even in big games. Yeah, you could make the case of, and that's a problem. First, an audio asterisk here. No one should take financial advice from me.
Okay, let's move on.
National administrators, the governors, the king's council together, and they saw these men on whose bodies the fire had no power. The hair of their head was not singed, nor were their garments affected, and the smell of fire was not even on them. Now listen to this.
Amazing.
Hello.
I'm going to keep this radio. I'm not going to give it back. I haven't even done the rest of the alignment yet. So that's 865. 865. Let's look at the. I'd say that's right on the money. You can't get much better than that. 865. Wow.
La lumière sur les problèmes de santé mentale. On va parler aujourd'hui de l'association. Continue to act as if they're still single.
Comedy Channel.
You think like
From Hamilton.
I'm still single, but now there's this long list I can't do. That's not how it is. You are now a couple. It's a totally different organ.
below 30 million viewers, according to Nielsen Records. And the
680.
all-time high was in 1998 when 55 million watched Tyson. Standing Committee on Public Safety met to discuss prison
640.
Conservative
strategy and why one Canadian company is better or more
610.
patriotic buy than another.
For the same reasons. Like
590.
it's more, to me anyways, as an outsider, it feels like fear of social
Tone
media
control.
more than actual feel of reprisal from a baseball team.
I think it should be both. I think
Wow.
both are.
Wow.
Both
Wow.
are,
Wow.
I think baseball is the last one to the party, right? You mentioned the NBA, and I have to give Adam Silver.
I think the variation in volume with the tone control, it's not just muffling it, it's also dropping the volume, is because the tone control capacitor is still the original, and it's a little leaky. So when we allow as much signal as possible to go through that tone control capacitor, it knocks the volume right out. Not just knocks the bass out. So I think that's a leaky capacitor effect.
You mentioned all the podcasts, but I mean, you watched
Buffalo? Buffalo's a long ways from here. And this might be Buffalo also.
I question Wrigley for that in the first place. Although, should I also say that if the Bills were...
You know, the problem here is I love tuning radio, so I spend a long time just tuning around, seeing what's going on. Let's go on the shortwave band. Okay, we're starting at 6 megahertz and working our way up to 15. Go fairly quickly down here. Something came and went. This is the Canadian time signal from Ottawa. Ottawa is about 400 kilometers from here. Check your watches. 30 seconds to go, so we're not gonna hang around here. That sounded a lot like WWD, didn't it? Okay, we're coming up towards 9 megahertz.
whole reason behind water.
I was waiting for that to happen.
The answer is which someone is baptizing is either threefold or onefold, and it can. Go with me to Romans, the 6th chapter. Romans chapter 6. Read with me from verse 3. Listen to how Paul is now speaking about.
That's teletype, but you can't hear the tone with it. You just hear a little. It's a sideband thing. I'd really like to pick up WWV at 10 here if we can do it.
Speaking about water baptism, says that you have been buried with him in baptism.
This is still below 10, I believe.
As you find in Romans.
That could have been a image. That could easily have been an image from a very, very strong station down here. But no sign of WWV. That's teletype. Yep, they still do that. More teletype. It sounds like a broadcast station that's interfered with. Thought we'd get a little more through there. Coming up on 13 megahertz. This is another shortwave band here. Shortwave broadcast band. Nobody? Ooh. Those pops you hear when I'm tuning quickly, where'd they go? Where'd they go? There. That's a station. I'm going by a station. Strong one.
Set you free and become the best friend you've ever had. Get a copy of Phil's new book from us. I could be wrong, but I doubt it. And you can call us for that. Our number's 800, the letter A in the word family. Or stop by the website. You can learn more. FocusOnTheFamily.com/broadcast. And while you're there, you'll also see a link to
So that's marching orders. So when I read that, I thought, I said, you know, when you get right down to it, it's not rocket science.
right, and he wrote it down for you. Here's that.
A lot of religious broadcasting in the United States. That's they kind of. Oh, here we are. Okay, this is WWV. There. So see the second hand just got across. Can you see it? Oh, fuck. Hey, these are great watches. Yeah, right. Okay, so we're tuned to 15, and now we get to look at the dial accuracy here. A little bit of parallax when you're looking down at it, but I'll look right across. So the 15 is this dot right here beside my finger, and you can see where the pointer is, just a little bit below. Not too far off. Not too far off. And there's another strong station. Usually up here. No, maybe not. No. Okay, so that's the performance of the radio before doing the rest of the alignment. It's really, really good. Actually, I'm going to shut it off here. It's very, very good. Hard to see how I'm going to improve on that. The dial is relatively accurate. I can get that a little bit better. But in terms of its receptive capabilities, I think it's probably at the top right now. How much more can it get? Remember, a radio can only reproduce what is on its antenna. So if your antenna is poor and the signals are weak and the noise is high, that's what's going to come out of the radio. And you can't do anything about that. So it's all about the antenna. And I've mentioned a couple of times I have a good antenna. I'm really quite impressed with the antenna I'm using. Beat the heck out of all the other wire nonsense I've done all my life. So with that antenna, a radio like this is working great. I think with a regular wire antenna, I don't think this would be quite as impressive. So if you had a really good wire antenna system, maybe with multiple dipoles at different lengths or something, maybe you could get really good performance out of a wire antenna, but or a long wire antenna. But you need a lot of property. You need to hang this wire somehow, and it can't be near anything. So how do you do that inside a town or an urban area? You use the kind of antenna I'm using. Okay, that's it for today. I see somebody has come to join me here, so I'm going to be on my way because the cat has come and said, "Come on, man, let me outside. The sun is shining. The sun is shining." Okay, thanks a lot, and see you on the next video. We will finish the RF, finish the alignment by completing the RF part of it. See ya.